In this video, we are going through digital transmission modes, digital transmission synchronization, and multiplexing. Now we go on to digital transmission modes. Let's start with parallel transmission. The data bits are transmitted using separate wires or circuit for each bit simultaneously. By using byte width transmission, theoretically it is faster than serial transmission. However, it has a skew problem for long-distance transmission. Each wire may delay the data pulse with different amount of time. The difference becomes more significant over longer distance. Due to the skew problems, it is not suitable for long-distance transmission. For serial transmission, the data bits are sent serially or bit by bit over a single wire. Therefore, it is slower than parallel transmission. But it is suitable for long-distance transmissions as it has no skew problem. Currently, it is the predominant method of transferring information in data communication. Now, we talk about data transmission synchronization. For data transmission, we either apply asynchronous transmission or synchronous transmission. For asynchronous transmission, the data are sent by series of bytes along a single wire. Each character is transmitted independently. Users start bit and stop bit to separate the characters. Its data rate is usually less than 64K bits per second. The transmitter and receiver circuits use independent clocks. For asynchronous transmission, it has low efficiency due to the need of start and stop bits. We call them the overhead. But it is ideal for short bit sequence data transmission. It is mostly used to connect PC to devices, and it has already replaced by USB. For synchronous transmission, data is transmitted in a continuous block. There is no start and stop bits, so it has a lower overhead. Synchronous transmission has a higher efficiency than asynchronous transmission. Because of that, it is used for longer bit sequence data. A clock signal is used to synchronize the transmitter and receiver. In synchronous transmission, the receiver retrieves the clock signal from the incoming data stream to ensure the accuracy of data. Since transmitter and receiver clocks are synchronized, so it is able to support higher data rates up to 10 gigabits per second. The transmitter sends characters in a block or frame. Special sync characters are transmitted at the beginning of each block. The receiver detects at the beginning of each block by reading the sync character. Synchronous transmission is widely used for connections between computer and telephony systems. Now we come to multiplexing. Multiplexing is a method for simultaneous transmission of several channels over the same transmission medium without interference. This is to share the expensive resources such as the transmission medium. The device performs the multiplexing is called a multiplexer. And the device performs the reverse process is called the demultiplexer. While multiplexing is the method for simultaneous transmission over the same transmission medium, multiple access is to allow several terminals accessing the same communication channel. Let's use an analogy to explain the need for multiple access. Imagine the people in a crowded room wish to talk to each other at the same time. To avoid confusion, people could take turns to speak or speak at different pitches or speak in different languages. Frequency division is one of the multiple accessing methods. In frequency division multiple access, the whole frequency band is divided into smaller frequency bands. For example, if the total bandwidth is 200 kHz and each channel is allocated with 50 kHz, that means the system can accommodate 4 users at a given time. Time division multiple access is another technique. For time division multiple access, it allows many users to share the same frequency band by dividing the signal into different time slots. The users transmit one after another using its own time slots. This allows multiple stations to share the same transmission bandwidth. Code division multiple access employs spread spectrum technology and a special coding scheme. Each user uses a different code to modulate their signal. The spread spectrum technique spreads the bandwidth of the data uniformly for the same transmitted power to better secure the system. Finally, we would like to discuss on the space division multiple access. In space division multiple access, it divides the geographical space where the users are located into smaller spaces. It provides one-to-one map between the space division and the bandwidth. It is compatible with any other multiple access techniques. Space division multiple access is also based on a technique called MIMO, multiple input, multiple output.